Okay, welcome to part 11. Right, of Shoot 'em, our little game, shoot each other in the face game. Um, right, I just want to improve something. Remember those player scores, you can reposition those as you like. Right, at the minute, we've got collision detection super simple. Okay, the center of the player is what we're detecting with the wall. It's a bit naff. Um, the problem with collision detection, it needs to be custom depending on what type of game you're doing. And one way we can do this is by generating collision points based on a direction we're moving. So if we're moving forward, we really want to check for points around the head of the player. Okay. And when we're going backwards, we want to be where the feet are. So we're going to create this little system. In order to visualize this, we're going to create a little highlighter sprite. Okay. So let's just start off by creating that. So if we right click on code and say add class, and we'll call it highlighter. Let's just zoom that in. Let's go to another method, another class, and copy the using statements. Let's just copy those, paste them at the top of highlighter. Now this is going to be a sprite. And what we're going to do is we're going to create the constructor so that it accepts a position to be placed, a size so we can change how big it is. We're going to have a duration for how long we want it to stay on screen, so we'll automatically get it to kill itself, and we'll have a color. Okay, so we're going to pass it 4 different parameters. So because this is a sprite, we're going to add that to the engine. Standard. We're going to define a frame, but we're going to use the engine's single white pixel. And then we're going to stretch it to the right size. So we're going to say position 2D equals pos. We're going to say scale both equals size. We're going to say the wash is to be set to the color. And then we're going to turn the timer subsystem on, timer initialize, and we're going to say timer.kill after, and then whatever the duration is. Okay, so that's a real little simple sprite. We don't have to do anything else. So it's going to kill itself after a certain amount of time. Right, if we go to actor, we need to add a couple of pieces of information to actor. Okay, so we need to know the relative position of our collision points for when we're moving forward and when we're moving backwards. So we're going to create a couple of private fields. So we're just going to say vector2, and we're going to store these in an array. So we do that in C# to denote that we're going to have an array of vector2s. So that's x, y coordinates. So we're going to call the first one collision point forward, or collision points forward might be a better name. And then we're just going to set where relatively we think the collision points are. So we're going to say in the braces, new vector2. Right, so from the center, we want one that's up and left a little bit. So that's going to be -10, and we're going to put -20. Okay, so left is negative and up is negative. So we're going to say 20 pixels up, 10 pixels to the left. We want another one that is going to be on the right hand side. So that's going to be 10 pixels to the right, but 20 pixels up. Okay, so we're going to create another list or another array for going backwards. So collision points backwards. And that's going to be new vector2. So we're going to go down and to the left. So we're going to say -10, but we're going to go 20 down. Where these actually need to be, we can adjust later if we want. And obviously it's going to be dependent on the graphic you're using. And then we want one down to the right. So that's 10 across, 20 down. So they're going to be the points we check. Right, so let's go to our control code because that's where the hits are done. So here's control of actor. And this is what we're currently doing. We're saying if the center of the sprite isn't on a path, we skip back. Remember, we take a copy of the current position before we update the positions. So it's this code that's going to change. So what we're going to do is we're going to create a new method that does the work for us. But we want the logic to stay similar. So what we're going to do is we're going to edit this if, and we're going to say if hit the map with the forward collision points. So we're going to give it a parameter, then we're going to revert back. Okay. So we're going to right click and we're going to generate the method stub. So that's for the forward one. Let's do the same for the backward one. So we're going to say call hit map, but we want the backwards collision points. Okay, right. So hit map's been created. So let's right click on that and go to definition. So you can see it's even created the parameter for us. It's giving it a stupid name. So we're just going to say we're going to rename that to collision points. I think might be better. So it's more general. So let's double click that. So collision points. And what we're going to do is we're going to run through each one of these collision points. We're going to work out where it is on screen. We're going to rotate it so that it's relative to where the player is. And then we're going to say, is there a bit of map here? And if there's map here, then we're going to end and say, oh no, we've hit something. Okay, so first off, we need temporary local variable to hold the position we need to test. And then we need to set a loop up. So we're going to say from naught, and then we say while I is less than the length of the collision points we've got, I plus plus. That's a standard loop for an array. Okay, so the first thing we're going to do is set up this point. We're going to say the point is the collision point we're currently processing, collision point I, plus the center of the sprite. So that'll give us the relative position. So that apply the offset to the center. Then we need to rotate that offset. Now we use the rotation helper for this. So we're going to say rotation helper dot rotate point around position. So this wants a reference, so the memory address of point, because it's going to modify it for us. Then we need to know what our center of rotation is. So that's the center of our actor. And the angle that we're going to rotate is whatever the rotation angle of the actor is. Not the, oh, gold. Do that again, Eric. Rotation angle of the actor. Okay, so that will put the point in the right place. Now we're just going to do a test. So we're going to say, and it's just like we had before, we're going to say level collider dot instance dot road here. So we haven't got road here. Oh God, I'm struggling here. Oh my Lord. Instance dot road. Dot road here. Had something's gone funny there. Point. If that is true. Oh, I've done something silly there. Ah, where's my road here bit gone? Hang on. Where's level collider? Let's zoom in. Path here. Oh dear, that's why. So path here. There we go. Path here. Always double check when you're being silly. Right, so if we haven't found a bit of road, then what we're going to do is we're going to say, right, I'll get out of here. There's no point in testing any more points. Tell the code that we have definitely had a collision. So if we just scroll up to control, so if that is true, we're going to revert back to our previous known OK position. Okay. But we also want to show the highlight. So we're going to say new highlighter. At this point, size of it, let's make it 10 so you can see it on the video. Let's have it on for 0.2 of a second, and let's make it red. Okay. Right. Oh, that's not a pay. Unreachable code detect. Oh, right. You must, before you do a return, put your code before a return. That was a bit silly. Right, if we get through this entire loop and we don't find a bit of stuff to collide into, we need to return false. Okay, now hitmap will stop moaning now because I'm always returning a value. So as soon as we find that we have hit something other than the path, we say, oh, that's it, we've collided. If we make it all the way through this loop without this being true, we return false. Okay, right, let's just see that in action then. So as I move around, you see that's where I've hit. So it's a little bit more realistic. If I reverse, it only checks my feet, but you can see the point. So the highlighting thing is quite useful to do that. So let's just have a look at what we've done again. And obviously I can put these points wherever I want. I can have as many as I want. It depends how I'm working my collision system. If I was doing a platformer, I would probably have, when I'm jumping, collision points to do with my head. When I'm falling, I would have collision points to do with my feet. And I wouldn't be interested in my head when I was falling, generally. Okay, so this is a really nice, super custom way of using the collision systems. Okay, so let's just recap what we've got. So we just worked out some offsets for some collision points that were relative to the center of the sprite. We modified our collision detection control code to run a method so that it was nice and neat that said, oh, use these points and see if we've got a collision. And then we just created a nice little simple collision detection routine that ran through each of the points, moved the collision offsets to the relative to the center of the sprite, rotated them based on the rotation of the sprite, and then checked. And we generated a little highlighter to show that we got a collision. Okay, that's the end of that one.